One way to increase speed is not to use Python at all, right? So if we call a function in, for example, the C programming language, that might be faster than calling the same function in Python. And you can call functions in the C programming language from Python if you compile it to a library. So here we have a simple program where we calculate I times j for the numbers 0 to 5000 for I and j. So the same program you've seen before, we can run it, and you'll see it took about 1.5 seconds to execute. Now we can have the same function, so this function in the C programming language. So here we have the same function, we have I and j, and then we calculate the multiplication for the numbers 0 to 5000. Now you don't have to be an expert on C to understand all this, but this is the same function in the C programming language. So what we'll do is compile this code into a library. So using this compile string. So let me copy that and clear the screen. So we have the C program, and we'll compile it using that string. Now my file is called test.c, and I'll call it libtest.so, and I'm using the GNU C compiler. So this will create a library with that function, and then you can use it inside Python. So by calling import C types, then specify to load the module that we just created, like this, and then you can call the function in the module. So this will do exactly the same. I'll run the program, and you'll see it did the same calculation. However, the speed is just totally different from the speed you are getting from the version implemented in Python. Now, just for clarity, what we can do is also output the variable z, just to show that it's the same. And if you run it, it will output all of it, all of the values. You can do the same thing for the C variant. So we can output the value. And you'll see that it's the same. So now if we run the function, you'll see it's also outputting the same numbers, but the C variant, of course, is faster than the Python variant. But now, because of all the output, we can't really see. We have to wait for the whole thing to complete before we see the speed difference. But you saw the speed difference before, where if we use the C version, it's just lots and lots faster. What we can do is add a total. We calculate the total of all of this. And finally, we'll output the total. So we do that in the C version, compile it, and we'll also do that in the Python version. Now we run them. So this is the version that calculates the sum using the Python function, and we can do the same thing using the C function, and you'll see the C function does the same thing, however in a lot less time. So by calling C function from Python, you can win a lot of time, and you'll see the numbers are slightly different. That's because floating points are not exact. But the function calls are the same, and you see that by calling C function from Python, you can win a lot of speed. So if you implement part of your code in C, you can really gain a lot of speed there. And you can do that by turning it into a C library like this, and then loading it using the C types module, where you load the shared library and call the function. So by calling the functions directly written in the C programming language, you can win in speed. However, that may not be true for PyPy implementation, because that's pure Python. So it will likely depend on which interpreter you use. So you'll see when you're when you're using the PyPy interpreter, actually it's slower than when you use the when you directly use Python, but that's just for the PyPy interpreter. If you use the C version of Python, so the default version of Python, what you'll see actually is that it's faster using the C function call. So, of course, calling a C function is only faster in the C version of Python, the default version. If you use the PyPy interpreter, actually it's slower, because it's slower with working with C code. But in general, if you use the default Python interpreter, you can win a lot of speed by calling a functions directly written in the C programming language.